Welcome back to Cloud AI Nexus 360, where cloud meets intelligent innovation. Today, we're diving into one of the most critical disciplines in LLM operations, observability. As leaders in AI and cloud architecture, our job goes beyond deploying systems. We create ecosystems that earn trust through transparency. Whether you're running Anthropic, AI21, Mistral, or Amazon Titan models inside Bedrock, you need visibility into what's happening behind the API calls. How's your latency trending? Are you staying under your token cost budget? Are there errors or throttles creeping in during scale-up tests? In this session, we'll deploy a fully automated observability stack using AWS CloudFormation. Let's connect it to Amazon CloudWatch and validate it with a budget-safe load testing script. Designed, formed for scale, safety, and insight. Stay tuned to the end. I'll show you how to visualize everything in a multi-model dashboard and share how architects think through observability as a leadership discipline, not just a technical one. Thank you.
In the world of LLM ops, observability isn't just logging. It's leadership through visibility. It's how we create systems our teams can trust, measure, and evolve. Our CloudFormation template lays the foundation for deploying a CloudWatch dashboard to visualize latencies, token usage, and errors. CloudWatch alarms that automatically trigger notifications. An SNS topic to alert engineers or ops channels when thresholds are breached. And an IAM role and log group that securely captures invocation data. In under 15 minutes, you have an enterprise-grade observability stack that transforms reactive troubleshooting into proactive intelligence. Let's talk about leadership through automation. CloudFormation acts as your control plane for observability, ensuring that architecture isn't left to chance. When you deploy this template, you don't just create alarms, you codify accountability. You define consistent thresholds across models, reinforcing operational excellence. You establish governance and auditability, turning chaos into structure. This is what separates good engineers from great architects, designing systems that enforce discipline by default. So whether you are running a proof of concept or a regulated production workload, your monitoring systems remain consistent, versioned, and compliant. Each Bedrock model gets its own health signature, reflected through these CloudWatch alarms. So essentially, this is the CloudFormation template, which we've designed to create a number of alarms. The first alarm we created was tokens per invoke. We also created latency. We created error rate, throttles, and obviously we could not create budgets, but it is somewhat implied indirectly with the tokens per invoke. So let's give an explanation of each of these. The first one, tokens by invoke, is essentially we've defaulted this to 1,500. And what this essentially means is that something usually heavy or expensive, each request is using too many tokens. So we've defaulted this to 1,500 tokens per request. And I'll later on go into the durations and the meaning. I'll just give you a table. I just want to go through some of these here. The next one is latency. And the latency is the P95 percentile. And that is essentially the invocation latency. The default threshold is set to greater than 1,500 milliseconds. This essentially is if the model is responding slower than the expected default, which is the 95 percentile, the response is termed as being over 1,500 milliseconds. The next one is essentially the error rate. So for the error rate percentage, we have a state whereby we are detecting reliability issues. There are too many requests, which is coming through with faulty with errors more than say 2% of requests is failing. So that will now classify it as being having errors. Then we have throttles, whereby it's essentially invocation throttles, the sum of those, where that is where we are detecting request bottlenecks. We are sort of forging, simulating, sending too many requests too fast, and Bedrock will not be able to handle that. So that's what makes the Bedrock rate is limiting you based on the defaults which we've set, and the duration is every 2 minutes. So I'll just show you. So this is basically the template, as you can see, and those are the various categories which you are going to be testing. And I'll just show you a table that summarizes all these pieces, all the alarm types here. And this is the default thresholds which have been set, and these are the respective durations. So each of these alarms reflects a dimension of operational health. Tokens show efficiency, latency reveals performance. Errors test reliability, and throttles expose scalability. Great architects know you can't lead what you can't measure. Thank you. So having run the CloudFormation template on the system to generate the necessary, to set up the alarms, the dashboards, etc., we basically noticed that the Bedrock by default doesn't stream invocation data. So this is where some bit of leadership comes in, whereby we need to enable some additional information if required in terms of your process that will help with future debugging. So in that stead, we essentially look for the log group as well as the role ARN in relation to the CloudWatch logs role ARN, and based on that, we that has to be done manually, so we use this command to input that. And this is, we're still looking at this from the context of the Lux Search AI travel assistant, whereby we are only interested in text data delivery. So that's why that was enabled. We've not gone haywire with images or movies or anything of the sort. So that is what we basically did there. And you can see from here, just to show you that the CloudFormation template was enabled. And these are basically the outputs. Sorry, the wrong one. So these are the outputs. You can see the dashboards being enabled there. You can see all the alarms which were generated, the various resources, which we are going to look into much detail on this later, etc., etc. And there's the same template as shown in the IDA tool. So essentially, with one command, we've moved from blind inference to data-driven visibility, a core tenet of LLM ops leadership. Thank you. Once login is enabled, step into your new LLM ops cockpit, the CloudWatch dashboard. You will see invocations per minute to gauge traffic patterns, latency distributions, whether the percentile be P50, P95, or P99 to assess user experience, error and throttle trends model by model, tokens per invocation, a direct measure of prompt efficiency, and multi-model comparisons to benchmark performance across vendors. This isn't just monitoring, it's a situational awareness for leaders. Every panel tells a story about how your AI behaves under real conditions. So I'm just simply going to demo the current observation, which we can allude to when it's working okay, before we do a bit of stress testing to sort of get the matrices above the thresholds. So what we are doing now, I've put in a request for, say, New York, and I've got this. I'm going to put in another request for, say, Sydney. It says it couldn't find anything. Let's try again. Okay. Let's try in London. Question is timing out. Okay, great. Give me another city we can use. Amsterdam. Unfortunately, when we go through the front end, we don't get to use the planner agent, so we wouldn't see it on the CloudWatch dashboards. But we're gonna get that invoked when we use like a test script. Okay. Let's see, Washington, DC. Okay. So we can see observability here, the Anthropic Cloud Sonnet. We can see the line there in terms of the latency, which is confirmed there. We can also see the count in terms of the number of invocations past the time. One invocation. Okay. We can also see the which one is this one? Number of tokens. So the number of tokens in terms of input and output. So we can see that the input tokens is say 2,986, 82, and the output tokens 148. So that's a comparison there. As I said previously, the AI21 Jamba is not invoked because I didn't set it up from the front end, but if I do it from the CLI, you're going to be able to see that getting some traction. You also see the invocations per minute, which is there, and likewise the error rate. There's no error rate so far which has been collated. So that's just to give you a glimpse of what's going on. So I was able to craft like a script to do some stress testing in relation to some of the thresholds we've configured as part of our CloudFormation template. So this is basically the script which I'm going to test run in just a few minutes. But let me just give you some context to this. So leadership is about testing systems before reality does. The Save Bedrock Load Tester lets you stress test responsibly, validating your alarms without overspending, and it includes guardrails for runtime limits, maximum invocations, tokens per call, as well as a budget cap. And you will note that the budget cap is sort of interpairs within the script itself, because in CloudWatch we don't necessarily have like a metric for budgets per se, but in the script we're able to do that, whereby it runs a bit of an algorithm which is going to apply. So it's not just a script, it's a discipline tool. So it helps architect. So what we're trying to do is essentially to simulate a situation whereby we're trying to perform some monitoring, where we've set some guardrails around some thresholds, and we want to enforce those guardrails. And obviously to flag to respective parties via Slack or via emails or via text messaging to your phones that there is something that you need to attend to. So it's going to help us to architects to stimulate, measure, and iterate safely, essentially to mark a mark of operational maturity, and that's what we are going to do here. So every observability pillar needs its proving ground. Here we have 4 key simulations that bring your matrices to life. The first one is going to be tokens per invocation, which is to do with cost efficiency. So we're going to run a particular script. To this particular script, as you see on the board, we're just going to put in a line of command with some hard limits as part of the script to sensitize the models, which is the Cloud Sonic model, as well as the AI 21 model. And the very first one is essentially, which I'm going to show you right now. So we're going to run a 7-minute stress test designed to force the token per invoke, essentially to jumpstart some, sensitize the models, so that we are going to be able to see some activity in relation to alarms on the CloudWatch dashboard. So as you can rightly see here, we have the idea is that each request is going to generate up to 1,800 output tokens, which is above the default threshold of 1,500. And we also note that CloudWatch requires 5 consecutive minutes of high token usage for it to basically spike. And you'll notice that we also included a budget figure there, which we've sort of crafted it into the actual script, which this is invoking. So I'm gonna run this now. So essentially, we can confirm that an alarm has since been triggered, and I'm going to show you the alarm now. It came in the form of email because the email was set up with the SNS topic, and I'll just show you what that email looks like. A variety of these emails came through. That's the first one. And you see it says you received this email because your Amazon CloudWatch alarm, Bedrock, high latency, 95 anthropic in the XYZ region, because the threshold crossed 3 out of the last 5 data points. Were greater than which the threshold was set, and 2 missing data points were treated as non-breaching, minimum 3 data points for OK alarm transition. So you can see that, and this is another one. You are receiving this alarm. We are having a bit of throttling in terms of Anthropic Cloud 3.5 Sonnet region has entered the alarm state because the threshold has crossed 2 out of 2 data points, which is greater than the threshold, blah, 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 blah. So you can see what is happening. The threshold has basically been breached. We are receiving another one. It says you are receiving this email because the Amazon CloudWatch alarm threshold has since been breached. Tokens per Invoke 1,500 anthropic, blah, 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 blah. So you can see what is happening there. We can go to the actual dashboard here. So let's see what has happened in the last, say, 45 minutes. And you can see what the dashboard looks like. Okay. So everything is working as expected. So I'm just going to run a few others and I'll essentially show you what's going on there just to see, for you to have a glimpse of what's going on. So this is sort of the graph, which is depicting the actual invocation latency. All the alarms are indicated here. Is essentially what we saw, but previously. But this is just showing the ones that are in the state of an alarm. So you can see where the cost is indicated there based on the little algorithm which was input as part of the actual script. So I'm going to run a couple of others now for you to just see what's going on. So here we're trying to load another observability pillar, and we're going to run a 7-minute test whose only purpose is to force the high P95 performance under load test in relation to latency. The CloudWatch alarm is hopefully going to trigger while capping the total spend to say $2. The idea that it's going to stop when it reaches 300 100 successful calls. Hopefully I wouldn't leave it to go that far. Okay. So this is to stimulate peak time behavior. As we said, leadership means knowing how your system behaves under stress. It's not just under success. Thank you. So as you can rightly see, we are getting some high latency in relation to the models which we have here. This one is saying that you're getting this email because Amazon CloudWatch alarm, Bedrock high latency AI 21 Jamba 1.5 mini version blah 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 in US East 1 has entered an alarm state because the threshold crossed 3 out of the last 5 data points, and this was greater than the threshold, which is 200, and it's saying and 2 missing data points were treated as non-breaching. And it goes down to, so you can, if we had to show this in terms of the URL link, we're going to get something like so, as you can see this here. So you can see the graphs, and that is going past the time, which is about 7:30 in the evening. So we can also see this, and you can also see that the time is similar. We can apply that duration. You can see what's going on here. And this is for the Jamba, the AI 21 Jamba. You can notice the graph in relation to latency. These are very, very powerful scripts which can be used for tests. At the end of the day, it's going to be shared within the GitHub repository. So the error rates percentage reliability, which we ran, running a 10-minute test that intentionally sends an invalid Bedrock request to trigger the error rate, and that was supposed to provide us some activity on the dashboard. And as you can see here, we did receive an email which is telling us that something is not happening as planned. The same sort of logic in terms of breaching some thresholds XYZ. And you can see here on the actual dashboard what we got. So remember, this is just a simulation, and this can be used sort of in real life if you, based on experience and agreement in terms of what your threshold should be, this can also be set according to expectation. You see it all in red. The alarm, the in alarm, it started at a particular time and it ended at a particular time. So let's go back to so it's gone. So successful calls is 0, estimate cost is 0. But this was sort of induced. I think this one might not, it might be very difficult to test this in its entirety. So we're going to run the last one now. And the last one is to do with throttles, whereby we're going to be invoking the models concurrently. So what are we testing here? We're essentially testing, and we're going to run this. It's hopefully a 3-minute test that tries to force Bedrock to throttle by sending, I think, 16 requests every second, while ensuring you never spend more than 50 cents. So let's see whether this works, and we'll see whether the alarm comes through. So the throttles in terms of concurrency tests, you can see it's ended. And what we try to do here is to gauge concurrency limits and how our systems behave when demand outpaces design. So this is ended here, and this is essentially the notification via an email. Obviously, this can be integrated with our Slack systems or any other enterprise systems that are used for on-the-fly access, as opposed to emails, which are not essentially that. Not many people respond to emails these days. So we can see the same sort of breach that has happened here. So I'll just go to the alarms, and you can see what's going there. We have concurrent invocation throttles, a number of these. So the invocation throttles happen for both the Anthropic Cloud as well as AI 21 Jamba 1 5 mini version 1.0. So if we go to Bedrock here, okay. We have the error rate. Errors and throttles. So you can see this one for AI21 Jamba. And we can see the other one for Anthropic. So for Anthropic, we can notice that we had 122 throttles, no client errors notified, neither were there any server errors. Okay, for Jamba, it looks as if there are no throttles at all. I think the throttles were coming on Anthropic. Okay. You will notice that some of the observability pillars in terms of the what we are trying to test were not, some of them were you could isolate them, but some of them you could not isolate them. So they are sort of interlinked. So one particular task might influence or invoke another matrix to trigger. So they're not, you cannot really isolate them in effect. So when we ran the throttles in terms of concurrency, we did notice that they were it triggered some of the other metrics around high latency in terms of the percentile of 95 for both AI21 Jamba as well as the Anthropic Cloud Sonnet. So that's something that we observed there. In relation to now, we can watch our models obviously breathe since we've concluded the test. Latency will say obviously stretches, count, token counts, rise, as well as throttles flicker, and allows pause, red, then green, and again, as you can rightly see here. So this is where engineering meets intuition. We are no longer just monitoring. We are listening into our AI systems, and these are going to be obviously in motion. So once alarms are tested, we fine-tune them. Great architects know that tuning thresholds is much as an art, as a science, and it's where governance meets empathy for the system. So these are just the matrices which we try to test. You can see we tested tokens per invoke, and that a lot centers around costs, cost optimization, latency is to do mostly with customer experience, as well as the likes of, say, performance efficiency in relation to AWS's well-architected frameworks, as well as things around error rates, operational excellence, throttling as well, And these all provides insights in terms of leadership, tokens per invoke, control costs without stifling creativity, latency, we balance performance with resource limits, error rates, percentage is tolerate learning and not failure, as well as throttles, which is to protect reliability as we definitely scale. These are not just settings, they are operational, or what we refer to as organizational guardrails, teaching your teams what healthy looks like. With this stack and testing framework, you know now that we have real-time LLM observability through CloudWatch. And I reckon that this is just the standard CloudWatch, as we tried to create this video on YouTube. I understand that CloudWatch has actually they've sort of created some features or capability within CloudWatch itself, specifically for LLM monitoring, and that's some great thing there. So I'm going to explore it and see whether it's any different from what we've done today. It also provides proactive alerting via SNS, and that could be integrated with a variety of downstream devices, whether that be email or Slack or maybe text messaging. We have a consistent governance baseline with CloudFormation in terms of the manner in which we deploy our resources, our services, and we have a safe validation loop using a load tester to make sure that we don't run over budget. So we sort of set those guardrails in place. Observability isn't just about metrics, it's about leadership visibility. It's how you build trust at scale between the models which we are going to be deploying in our production workloads. It's about our infrastructure and your teams and your organization. You can't optimize what you can't see, and you can't lead what you don't know how to measure. Thank you. If this has inspired you to elevate your LLM ops game, subscribe to Cloud AI Nexus 360, where you don't just explore technology, we redefine cloud leadership. We always ask you to subscribe to our channel, hit the notification bell, as well as send your comments or hit the like button. So it encourages us to bring you amazing YouTube content as we continue to explore some edge use cases. Until next time, keep leading with clarity and keep your clouds observable, especially your LLM workloads. Thank you.